ይታያል ወይስ?
ይታያል።
ይታያል።
እሺ እንጀምር መሰለኝ። አይ ሆፕ ሁሉም እንዲገባ well now let us start our discussion. As you have remembered, the last class we have seen about the overview of big data, and we have seen also about the properties, characteristics of big data, and advantages and disadvantages of big data. Even we have seen about types of big data, like big data analysis. We have seen from different perspectives, and we have compared with various technologies like data warehouse, data mining, Internet of Things, and so much. And we have seen also sources of big data that we can get a large amount of data from social media, from business sectors, from different institutes. So that big data is historical. Usually it may be historical data or it may be online data. And the big data, what it makes different from the other is it can capable to handle a large amount of data, and it needs special tools for analyzing that big data. And we have seen also the reason why we apply big data, because data is increasing now exponentially, and it is very difficult to control. And data, I mean, different business sectors need a very large amount of data, especially unstructured data. And that unstructured data is untouchable so far, especially in developing countries, but it is the main source for business. And it can be applied in everywhere, and it is multidisciplinary, including health sectors, telecommunication, and different business sectors. And it helps to improve researches and sciences, because almost all of the researches are inclining toward the artificial intelligence as well as data science. And when we see the course, we have seen basically three main problems, like the cost of the professionals, the privacy issues, and overwhelm problems for writing or for solving problems. These all are what we have seen last time. Now let us start big data techniques. እዚህ ጋር መሰለኝ ያቆምነው። ይታያል ያለውበት ቢግ ዳታ ቴክኒክ። አይሰማም?
ይታያል።
ኦኬ well so this class, I mean, let us see this chapter, and we start chapter 2, big data technique. Yeah, there are, as I told you, there are a number of data. There are varieties of data. The data production is exponentially increased, so that's very difficult for implementing, unless otherwise we know the target, or we know how we can implement. So there are different techniques like massive parallelism, or data distribution, or high performance computing, or task and trade management, or data mining and analysis technique, or data retrieval technique, or machine learning technique, or data visualization. These all are about 8 techniques that we can apply in big data processing. So if we say that the massive, a lot of tasks can be parallelly processed using a number of memories or a number of independent memory, and then we can integrate at the end. That is called massive parallelism, and this is usually it is used for distributed computing system, and it is not that much recommended for the current working environments. And there are also distributed data distribution. This data distribution, we can distribute data sets or large data sets for different, different big data analysis components. Like we can put at the center, like centralized approaches at the main server, and then everybody can act on that. Like GPU or graphical processing unit can be used as a centralized approach, or semi-centralized approach. It is somewhat is a server-based and peer-to-peer network system approach, and everybody can involve on that, but they have a limited privacy or limited privilege. Or there may be hierarchical approach, which is a data fetching from parent nodes and then sub-parent nodes and then child node and so on. Or peer-to-peer approaches, like an approach that can be done in big data within cloud computing or ad hoc network system. So we can apply this peer-to-peer approach. The other one is high performance computing. This is one big high performance computing can be stayed at the university level, which is, for example, okay. So this distributed approach, an approach that can be used for computing a very large amount of data sets. That large amount of data set can be processed at the cloud system, for example. So this is high performance computing. And I don't know how much GPU the Gondar University will have, or how much computing, high performance computing servers they have. But as you have remembered from the conference, the Ministry of Education have their own high performance computing system for that used for sharing for scholars, so that you guys can request to give you the partition or high computing performance, online high computing performance system, and then you can do your work there in education, Ministry of Education. And the other one is task and trade management. That task and trade management usually it uses for the task has been divided into sub-components, and then they can be processed through the parallel system. As you have remembered from the machine learning course, tasks can be done using parallel computing or transfer computing, if you have remembered, or if you have taken the course, data machine learning course or artificial intelligence. This task and trade management is one of that task. It is a task and trade management. That task and trade management, it process the task through dividing sub trades, and then parallelly processing that, and then at the end they can combine and take the optimum outputs. And the other point is about data mining. This is data mining, extracting very relevant information from a huge data, which is inside information, inside very relevant information from a huge data set. That is, it is called data mining, and data extracting data, and then evaluate it, and then transpose, and then summarize it, and then execute the summary or report it. That is the task of data mining. So big data can be done using data mining. So whenever we say that big data is nothing, it can show the complexity of the data, but it can be we can apply data mining and analytic technique. Even you have taken data retrieval, am I right? So when you see data retrieval or this data retrieval, it uses for extracting huge data in the search engine. So that's what big data different from the other is. It uses a Hadoop and Hadoop distributed file system architecture to retrieve large data sets from, like for example, from Google or from Yahoo or from majority of web systems, huge web systems. They use the Hadoop application. And ኦኬ በቶሎ ብትገቡልኝ ደስ ይለኛል። በጣም ብዙ ሰው ዘግይቷልና እያቋረጥኩ ነው እየተቀበልኩ ያለሁት። Well, now this big data technique can be used also machine learning. You see, so you guys are taking now different courses that can be applied, that can apply for processing big data. You may use or you may take data mining, or you may take machine learning, or you may take whatever, any course, information retrieval. That all are used for processing the big data. So big data analysis is very mandatory for every discipline. Machine learning, it is a program computing that uses for optimizing or to executing or creating knowledge from the past experience. That is, it is called machine learning. It is sub-artificial intelligence component, or it is a part of artificial intelligence that uses for develop a model that can comparatively equivalent or better than human mind. That is, it is called an artificial machine learning. So machine learning is a system utilizes multiple algorithms, as you have remember. I will show you in chapter 3 about machine learning. There are a number of machine learning courses that will use for varieties of purposes. So there are classification algorithms, there are regression algorithms, there are reinforcement algorithms, there are deep learning algorithms. We are going to see these all. And there are also data visualization. So whenever you guys write the research, you have to explicitly describe that what type of technique you are going to apply. Are you applying data visualization? Like, for example, if it is in the mapping system, or are you using machine learning? Are you using IR for big data, or Hadoop extraction mechanisms, or are you using data mining technique? You have to put explicitly your technique for what purpose you are using now your machine learning course. I mean your big data. So whenever we come to the challenge, there are a number of challenges. Like big data, as I told you, it is a security problem, and it is very distributed, so that it is very difficult for sharing data or exchanging data. Since it is huge, it needs too much amount of bandwidth. Even it needs too much data storages, and human consumptions of the result of big data analysis is very, very difficult. It is very difficult for visualization, because all of the data from the big data, I mean, from the collected data, they are not equally important. They are not equally important. So it needs some pre-processing for filtering out unnecessary data. So human expertise is very mandatory or very required for that, alleviating that challenge. And the other very interesting in this chapter is big data analysis tools and technology, or sometimes it is called ecosystems. Big data analysis cannot be just standalone. It is not standalone. Or tools of big data analysis, they are not single tool or technology. They are integrated technology. Whenever we say that Hadoop alone is not working or functional, Hadoop is something, it is a technology or a tools that uses for storing data. Yeah, it's nothing. And there are also varieties of components that may be used for the big data applications. Of course, Hadoop is a backbone, or it is the mainstay components of the big data processing, because all of the data from the real environment or from the historical data, they are stored in the Hadoop. And the other component is not only SQL. So far, I hope all of you guys are using the structured data or SQL language database. But Hadoop uses something special, non-structured data, like XML or any data type, like image data, which is unstructured data, semi-structured data, or structured data. Structured, semi-structured, quasi-structured, or unstructured data can be stored in the special database, which is called, or format, which is called NoSQL, or not only SQL. As you see from the graph, let me show you. Yeah, here you see the structural form can be used from the top here, the warehouse, something, business analyst, and so on. But from the bottom one, it is the big data one, which is a flat data set. It is very difficult for managing such type of data. Like, for example, we can use the Spark for data acquisition purposes, for data collection, and then this data can be stored in the Hadoop. And then once the data is stored in the Hadoop, it can be analyzed using the Spark. Then it can be visualized as output like this, graphical. So such a type of data representation, it is one of the ecosystem for big data. Map reduction is another ecosystem that uses for mapping or that uses for filtering from one to the other and then organize or reducing the size for visualization purpose. So during visualization, the data cannot be displayed as it is. It has been reduced in the big data because of the bandwidth or because of the memory or because of a lot of things. So they have been reduced but not affect the data contents. And then the other one is yarn or yet another resource negotiator. It is another component that uses for scheduling purpose. See, they use for scheduling. This is scheduling. So Hadoop has a lot of components. There is also a Spark. It is an open source clustering component framework that uses for implicitly data parallelism and fault tolerances. There is also the Tableau, which is end-to-end data analysis, and it is for displaying the final output for visualization purpose. So as you see from the graph, the Hadoop has two components. The top part is the map reducing component, and the lower part is the architecture, which is Hadoop, the data, the Hadoop defined file system, which is the file is stored here, and then it has been reduced, and then just map towards the user to the final end users. So this is the Hadoop is a general architecture, and it is about how the architecture this Hadoop file system has been done. Like there is a client and there is a different operations. As you know from the file system, there are mainly two operations: the reading operation and writing operation, and then the combination of the reading and writing components of the operations. And that Spark is the very amazing software, which is the Spark software. Apache Spark is an open software unified analysis engines for large-scale data processing. And you guys, you will have an assignment for doing such Spark and Hadoop installation in your computer for the next time. So the Spark ማነው አስራት የሚባል ልጅ ትምህርት የለም ወይ ያለ ነው። ምናልባት ሸር አልተደረገለትም ያ ኦኬ ሸር ተደርጓል አይደል? የኤክስቴንሽኖች አሎ
አዎ ተደርጓል፣ ሸር ተደርጓል።
ምናምን ሆኖ ነው
ዶክተር አክሰፕት አልተደረኩም ነው የሚለው ያለ
ምናልከኝ
አክሴፕት አድርጉኝ አልተቀበሉኝም ነው የሚለው ያለ ኦንላይን
አላገኘሁትም። ምናልባት እንደገና ሪኩዌስት ያድርግ። አላገኘሁትም፣ እየጠበቅኩት ነው። ሀያ ሰባት ተማሪ ነው የሚታየኝ። Okay. ሲገባን ተነግሯለሁ So Spark is the very interesting software. It is open source software that uses for implementing big data, and usually it has been written in R software, Java, or using Python. Usually, we are recommended to use R or Python softwares, and Scala software, or programming, or Java. These all are used for implementing the Spark implementation. And this Spark implementation, it is used as an interface between the bottom and the top one. And we have different softwares in big data. One of the thing is Hadoop, and the other one is Kubernetes. You can use a Kubernetes or you can use a Hadoop. But for the time being, let us use Hadoop. Whenever I was a PhD student, I was using this Kubernetes. And currently, I'm just teaching on this Hadoop. So this Hadoop software is something is a good software that helps us for managing. Okay, that can be all. Asrat, ገብታል አስራት እባክህ አታርፍድ Well, so this Spark software is very interesting and very mandatory for you guys for your future career. And I recommend you guys to use Hadoop with a Spark and with a Python programming language. Hadoop, Spark, and then Python. So these three very mandatory and interesting and recent softwares are very good for implementing data science or big data. And if you need to interest, the Spark and the Hadoop, you can use a Spark only, or you can use Hadoop with Spark, because Hadoop by itself cannot implement the big data, but Spark by itself it can handle the data with Spark Hadoop, and it is very scalable and it is usually very fast compared to the Hadoop. Hadoop is, since it is very huge, it is slower compared to the Spark. And here it is a comparison of Spark and Hadoop. I will already put here in the table. And future of big data. In the future, when you see the future, you guys, I recommend you guys to do your work in big data, not only for salary. There are a lot of works out of the world. If you are interested in data science, you can read, you can practice this Hadoop and Spark, and then you can look for jobs, online jobs. You may get about 500 USD or 1,000 USD or 1,500 USD or 2,000 USD, depending on the work. So it is very interesting work, and it may help you to change your life. 85% of the future, for example, in the future, 85% of the future, 500 companies are ill-prepared to exploit big data. You see, 85% of the Fortune 500 companies, the Fortune 500 companies, they are ill. 85% as a sample. Very difficult. So that the big data scientists, they need very bad. By 2015, for example, 4.4 million IT jobs globally will be created. You see, አሁን አብዛኛው የኛ ሰው ስራ የለም ነው የሚለንና እኔ አንድ ሚውት አድርጉልን እና እየቆላ ያላለ መሰለኝ። ደርሶልኝ ፕሊዝ ደርሶ አስወጣለሁ። ደርሶ እንዳላስወጣ ደርሶ እኔ የሚረብሸኝ ካለ አስወጣለሁ። ሶሪ ፎር ሴይንግ ዲስ። መረባበሽ የለብንም። ዌል ሶ ዩ ሲ በ2015 የአይቲ ስራ ቫካንሲ የወጣው 4.4 ሚሊዮን የሚሆን ጆብ አይቲ ጆብ ግሎባሊ ወጥቶ ነበር። ቢግ ዳታ ላይ 1.9 ሚሊዮን ጆብስ ኢን ዘ ዩናይትድ ስቴትስ ነበር የወጣው። አሁንም ላት ኦፍ ጆብ ያለ አብሮ ዘ ካንትሪ። ይሄን ያህልም ደግሞ ስራ የለም ማለት ሰራተኛው የለም። they are busy so ዳታ ሳይንስ ቀላል ስራ አይደለም። the digital universe is doubling every 2 years and will reach 40,000 exabytes of 2020. you see ዳታ እንዴት እየጨመረ እንደመጣ fewer than 1 in 5 business reports being expected where they want to be in managing using data. አያችሁ ከአምስት አንድ እንኳን ይሁን ዳታን ማኔጅ የሚያደርግ የለም እና ዳታ ሳይንስ just the main leading job. It will be the main leading job in the world, and currently the most developed countries are paying a large amount of money for those data scientists. So you guys can be a data scientist. I do have online jobs, and that online job is the data science work. So you can practice on this Hadoop and the Python programming language and the Spark application or framework and tabular framework, and then you can implement remotely. You can have the work abroad from, apart from Ethiopia. You can stay here, but you can get money, a large amount of money from USA or from Europe or from anywhere. Where we can apply, yeah. You can apply. Therefore, please, ደርሶ እኔ ከዚህ በኋላ እንትን እላለሁ ሪሙቭ ነው የማደርገው። ፕሊዝ ዶንት ዲስተርብ ዮር ፍሬንድስ። So big data can be applied in different sectors. You guys may have different work. I hope one of you or 2 or 3 of you can work in healthcare environment, health environment. So you can do, you can apply this big data analysis. You can apply different implementing techniques for your work, for your research. Natural resources, educationists, you can apply in education. I hope 1 or 2 of you guys may be teachers in high school or somewhere else. Insurances, you can apply insurance. You can get data from insurance, and you can apply data science for analyzing purposes. So you can contact them, and you can ask them some sponsor, and then you can do your work for them, and they can give you money. Criminal detections with the government, you can do a lot of work. So in bank system, in social network system, there are a lot of workers that you can compare. You can compute in the university to get many. And there are big data analysis challenges, some challenges just beside to the big data challenges that we have seen before. There are also some challenges like needs for synchronization across disparate data sources. Yeah, since there are a lot of data sources in big data, they may be difficult for synchronizing or just bringing together or making a relation with those data sources, or there may be acute shortage of professionals. Yeah, big data, the professional and the data growth unproportional. Currently, they are unproportional. They are very difficult for I mean, just managing the data source, because there are a number of sources, there are a number of exponential products, but majority of IT professionals are expecting the government works only. Getting meaningful insights from the data, all data may not be important, so we have to have something to filter out data, just selecting data, filtering data. That is called insight, very meaningful data. Getting voluminous data into the big data is platform. It is very hard, yeah, because Hadoop it is a new technology, so that it may take you time for just advancing your skill. Data management, data storages, there are a number of headaches. Security issues, privacy issues are another very essential and very difficult issues that we should address for implementing big data. These all are, some terms of the big data. Then you will have some exercise you can practice. But I do have one assignment. Assignment one. This is individual assignment. Select a paper. SCCI index it. And summarize it in a page. The summary should be, whenever you do the summary, you guys should work like background, issues, and because the issue is very mandatory, the issue, objective, or goals, goal, technique, and finding. These are very mandatory within a page. So due date will be 1 week, yeah. Not to, that's it may be too much. 1 week, like Saturday on 4. So February 4, 2023. This is your assignment. I will show you guys updated slide. Slide ትንሽ update ያደረኳቸው ነገሮች አሉ. Chapter 1 I will show you guys. Do you have any question? Any question you have on chapter 1? Any question? Any question? ጥያቄ የለም? ቻፕተር 1 ላይ ጥያቄ ያለው ቅዱስ እጅ አውጥተሃል። ቀጥል።
አመሰግናለሁ። ኔክስት ዊክ ቅዳሜ ኤግዛም አለንና ዲዩ ዴታን ትንሽ ረዘም ብታደርግልኝ።
ቅዳሜ እስከ ቅዳሜ ድረስ ነው።
ኤግዛም አለን ቅዳሜና ትንሽ እንዳጅን ትነዛለች።
ኦኬ 8 እናደርገዋለን።
እሺ
ሌላ አለ? any question you have? ገብቷችኋል? ግን እስኪ አስተያየት ልቀበል ከእናንተ ምናልባት ትንሽ የምፈጥን ይመስለኛል። ያው እሺ አለሙ
ይቅርታ ያው የመማር ማስተማሩ በጣም እኔ እንግዲህ በግሌ በጣም ነው የተመቸኝ። በተለይ ከዚህ ከሪሰርች ጋር በተያያዘ ያያያስክ ሪል ወርልድ ጋር ያያያስክ የምትነግረን ነገር ሪሰርች ላይም ያለብንን ጋፕ የሚሞላ ነገር ነውና ቢበረታ ነው። ያው ከጊዜው መጣበብ ጋር በተያያዘ ያው ኮንሲደር የምታረጋቸው ነገሮች እንዳሉ ሆኖ ሪሶርሶችን ቀደም እያልክ እየሰጠህን ያነበብንም እንድንመጣ ቢደረግ ይሄ ነው ያለኝ አስተያየት። አመሰግናለሁ።
በጣም አመሰግናለሁ። እሺ you guys አንድ ነገር አድቫይዝ ላድርጋችሁ። በእያንዳንዱ ኮርስ በተለይ ነው የማስተምረውን ትምህርት ስታዳምጡ አንዳንድ ሪሰርች ኤሪያዎችን እናወራለን እና ሁሉ ጊዜ ማስተዋሻ ላይ ጻፉ። እኔ just let me tell you my experience መምህር ሲያስተምረኝ የማስተዋሻ መጨረሻ በጀርባ በኩል ሁሉ ጊዜ ሪሰርች ታይትል ቢል በእያንዳንዱ በመማርበት ትምህርት ስማርም ታይትል ሲነግረን የሆነ ኢሹ ሬስ ያደርግም ታይትል ጽፍ ነበርና እዚህ ከመጣው በኋላ ተማሪዎችን አድቫይስ ሳይረግ አብዛኛውን ታይትል የምሰጣቸው ከዛ ነው የተማሪ ምክንያቱም ሁሉን ልሰራው አልችልም። በጣም ብዙ በየክላሱ በየፕሬዘንቴሽኑ በየሴሚናሩ ታይትል ጽፍ ነበር። ሶ ከደብተራችሁ መጨረሻ ላይ ወይም አንድ ደብተር ቋሚ ደብተር ሊኖራችሁ ይችላል። ታይትል የምትጽፉበት ስታነቡ ታይትል ትጽፋላችሁ፣ ሰው ሲያወራችሁ ታይትል ትጽፋላችሁ፣ ስትማሩ ታይትል ትጽፋላችሁ፣ ፕሬዘንቴሽን ላይ ሴሚናር ላይ ስትገቡ ታይትል ትጽፋላችሁ፣ ወደ እናንተ ታመጣላችሁ። ሶ ይሄንን ፕራክቲስ ብታደርጉት ጥሩ ነው ብዬ አስባለሁ። Well, I will share you this chapter for you guys. Now let me okay now let us start chapter 2, which is chapter 2. It is about getting to know your data in this chapter ነው ቬሪ ኢሴንሻል ቀላል ነው ግን ደግሞ ለአንድ ተመራማሪ በጣም አስፈላጊ ነገር ስለሆነ የተወሰነ አቴንሽናችሁ ሰጣችሁ ነው ክላሱን ጨርሰው ቻፕተሩን ጨርሼ ነው የምንለያየው ግን በጣም አሳጥርላችኋለሁ ያው ዛሬ በዓል ስለሆነ ብዙ ጊዜ ግን ቬሪ ማንዳቶሪ ወይም ኪ ናቸው የምላቸው ነገሮች ለታሪካችሁ እንለያያለን። ናው data and objects and attribute types, basic statistical data visualization, measuring data similarity and dissimilarity. እነዚህ በጣም አስፈላጊ ናቸው። በተለይ ዳታ ቪዥዋላይዜሽን፣ ዳታ ሜዠርመንት ኤንድ ስታቲስቲካል ሜተድ ኋላ ላይ ሪፖርት ስንጽፍ ሪዛልት ሴክሽን ላይ ሜቶዶሎጂ ላይ ፕሮፖዝ ያደረግነው ሜተድ ሪዛልት ላይ ሪፍሌክት መደረግ አለበት። ስለዚህ ኢንትሮዳክሽን አንድ ሪሰርቸር ስቴትመንት ኦፍ ፕሮብለም ላይ የተጠቀሰው ችግር በሜቶዶሎጂ መታገዝ አለበት። በሜቶዶሎጂ የተጠቀሰው ችግር ሪዛልት ላይ ሪፍሌክት መደረግ አለበት። እነኚህ ሶስት ነገሮች ኮሪሌትድ ካልተደረጉ ምርምር አይሆንም። So data objects and attribute types. Data object mean that it is an entity. Sometimes it is an entity, or that contains records. It may be represent as record in table forms. It may be represent as graph forms. It may be represent as network forms. It may be represent as order forms or special image forms. There are a number of techniques that can be represent data. So data, it may be in matrix form, or it may be in a flat text form, or it may be image form, because in big data, as you have remembered, the whole data are not structured data types. So we should worry about the dimensionalities, the data. ካራክተሩ ዳታ ዳይሜንሽኑ ለምሳሌ ቢግ ዳታ ላይ ያደረጋችሁ ሄልዝ ላይ የሄልዝ ዳታ ኮሌክት አድርጋችሁ ቢግ ዳታን አፕላይ ያደረጋችሁ ነውና ማሽን ለርኒንግ አርቲፊሻል ኢንተለጀንስ አፕላይ ያደረጋችሁ ዳይሜንሽኑ የቨርቲካሉ ዳይሜንሽን ወይም ደግሞ የኮለመኑ ዳይሜንሽን በጣም ብዙ ቢሆን ሞር ዛን 100 ሞር ዛን 1000 ቢሆን ፐርፎርማንሳችንን አፌክት ያደርገዋል። ሶ ዳታ ዳይሜንሽኑን ሪዲንግ የምናደርግበት ቴክኒክ ያስፈልጋል። ዳታ ሪዳክሽን የምንለው ማለት ነው። there is a sparsity, there is resolutions. ኢሜጅ ላይ ለምሳሌ ሪዞሉሽን የምንለው አለ። የኢሜጅ ፕሮሰሲንግ ወይም ኮምፒውተር ቪዥን የሚባል ኮርስ መውሰዳችሁን እርግጠኛ አይደለሁም፣ ግን ኮምፒውተር ቪዥን ላይ አፕላይ ስናደርግ የአንድ ኢሜጅ የሲስተሙ ፐርፎርማንስ የኢሜጅ ኳሊቲ አፌክት ያደርገዋል። ሶ we have to worry about the visualization of the images and centrality and distribution, where we apply or where we implement the data. That is called the centrality of the data or the objects. These attribute types, there are a number of attribute types. ለምሳሌ machine learning, wherever you apply machine learning in a numerical data, both numerical and binary or nominal data sets, it is not easy, or it is impossible to apply similar performing mechanism for the numerical and nominal data types. So we have to encode the nominal data into some numbers so that we can implement the machine learning. So variable, it is very mandatory, the attribute types. Numeric types, there are a number of numeric types, degree Celsius numbers and so on. And the other one is some data type may be continuous attribute, and the other one is maybe discrete attribute types. The countable and uncountable variable types are very mandatory. But statistical distributions, when you have a data set like, for example, mortality rates of female during pregnancy, for example, mortality rates of female during pregnancy in Amhara regional state, one of the research area can be using artificial intelligence. You can apply the big data principle or technology to study about the mortality rate of our mothers, our sisters, our children, and so on. So where the majority of the female is dying now, is that in the city, is that in northern part, is that in the central Amhara, is that in the eastern Amhara, is that the western Amhara? We have to study that. That is called data distribution characteristics, like median. Average mortality rate will be calculated using median. ማክሲመም የሞተበትን አካባቢ ብንፈልግ ከሆነ ሚኒመም መቼ ነው የሞተው፣ የት አካባቢ ነው፣ ኳንታይል፣ አውትላየር፣ ቫሪያንሱ በልዩነቱ በየወሩ ያለው ልዩነት ምንድነው? we have to study that. That will be this part of the data science. Numerical dimensions correspond to the stored intervals. Just the precisions, the recalls, box plots. That is just the plotting. በግራፊካሊ እንዴት አንድን በናምበር የተቀመጠን ግራፊካሊ with ኮንቬንስ እንደምናደርግ ዲስፐርሽንስ የዳታ ዲስፐርሽኑን ፎልዲንግ ሜዠርመንቱ ምን አይነት ቴክኒክ ነው የተጠቀምነው? ለምሳሌ ሚንን ካልኩሌት ስናደርግ ነው ካልኩሌት ያደረግነው ፍሪኩዌንሲ ቢኖርስ እነኚህ ፎርሙላዎች አንድ ሰው በጣም ይረብሸኛል ግን ከእናንተ ውስጥ
አስራት ከሚውት አድርገው
ሚውት አድርገው ነው እና ጥፋት ሚውት አድርገው በቃ ምን ይሰራልሃል? በቃ ሚውት አድርጌያለሁ። ጓደኞቻችሁን ነው የምትረብሹና ባካችሁ ራሳችሁን ትናፍቁት። So the mean value is going to be calculated using if it is single number like this, the green one. If it is sample mean calculate የምናደርግ ከሆነ the yellow one. If the mean, I mean the number has the variable has a number of frequency, then the red one can be used. And then the median, median value with the whenever the odd or even numbers, you have to use this formula. And the mode, maximum ከፍተኛውን most frequently happen የሚያደርገው ያ mortality rate most frequently happen የሚያደርገው የት አካባቢ ነው? That happening now in North Gondar? Is that happening now in West Gojam? Is that happening now in North Zolo or East? West Zolo, or is that happening now in Shaw? Such a type of technique it uses for finding the most frequently happening, so that you can recommend to the government to acting on based on that issue, that problems. The other one is what type of data distribution we have, timemetric or asymmetric type. That they have, are they correlated positively or negatively? You see, ዳታው ምን እየሆነ ነው? እየጨመረ እየቀነሰ ነው? ኔጌቲቭሊ ነው ስኪውድ ያደረገ? ፖዚቲቭሊ ነው ስኪውድ ያደረገ? ምንድን ነው ዳታ ዲስትሪቢዩሽኑ? አማራ ክልል ውስጥ ያለው የፕሬግናንት ፊሜል ሞርታሊቲ ሬቱ ተመሳሳይ ከሆነ ሚን ሚዲያ ሞዱ አንድ ቦታ ላይ ይገኛል፣ ዲስትሪቢዩሽኑ እኩል ነው ማለት ነው። ስራውት አማራ ሪጅን ኦል ኦፍ ዞንስ ኢኳል ሞርታሊቲ ሬት አለው ማለት ነው። ኢኳል ሞርታሊቲ ሬት ከሌለው ደግሞ የት አካባቢ ነው ማክሲመሙ ያለው? ሶ ዛት ገቨርንመንት ወይም የክልሉ መንግስት በጀት በጅቶ አክቲቪቲ ውስጥ በዛ አካባቢ the other one is someone Aduman. Okay. Then the other one is the very important thing is about measuring the dispersion of data. How we can measure dispersions? ምንድነው የመጀመሪያው ኳድራቲክ 25% ነው፣ 75% ነው፣ 1%፣ 0% ነው፣ 100% ነው? ማክሲመም ሰው ሃይሊ አፌክትድ እየተደረገ ያለ የትኛው ፓርት ነው? 75% ፕሬግናንት ፊሜል ነው እየተጎዳ ያለ ወይስ 100% ፕሬግናንት ፊሜል ነው እየተጎዳ ያለ የሚለው የምናጠናበት measuring the dispersion of data የሚለው ይሆናል። property of normal distribution curves በነገ ዳታችሁን አናሊሲስ ሰሩ 68%ን ዳታ ለሆነ ፐርፐዝ ካለው ዳታ ያለው ዳታ ሙሉ በሙሉ አንጠቀመውም እና ዳታ ዲስትሪቢዩሽናችን ኖርማል ከሆነ በ68% በ95% እና 99.7% ቴስት እናደርጋለን። አሁን ይሄ ሳይንቲፊካሊ አፕሩቭድ የተደረገ ነው። ሶ የ68% ላይ ጥሩ ፐርፎርማንስ ካለው 95% ላይ ጥሩ ፐርፎርማንስ ካለው 99.7% ላይ ጥሩ ፐርፎርማንስ ካለው ሞዴላችን ስኬሌብል ነው ማለት ነው፣ ወይም ሞር ጀነራላይዝድ ማድረግ ይችላል ማለት ነው። አዘርዋይስ ለምሳሌ 68 በትንሽ ዳታ ጥሩ ፐርፎርማንስ ሰጡ ዳታ ሳይዙ እየጨመረ ሲሄድ ፐርፎርማንሱ የሚቀንስ ከሆነ ወይም አኪዩሬሲ የሚቀንስ ከሆነ ይሄ ማለት የጀነራላይዜሽን ኢሹ አለበት ማለት ነው። ሶ at the end of the day ሞዴላችሁ የሚጠየቁ ሪሰርች ላይ do you think that your algorithm, your model is generalized or that works specifically for a specific task only for your data set? Generalized ማለት for varieties of data sets in a similar domain perform ማድረግ የሚችልበት ዳታው ሲጨምርም ሲቀንስም ፐርፎርማንሱ ማይቀንስ ማለት ነው። ይሄንንም we have to check that whether the work is properly tested in different ratios. And አንዳንድ የግራፊካል ዲስክሪሚኔሽን ዳታን ግራፊካሊ ስካተር ዳታውን የግራፊካሊ ሪፕሬዘንት እናደርጋለን። ይሄ ወርክ ከኔ ስራ ያመጣሁት ነው። the work has been bring for my previous work whenever I was a PhD student here. You see ሚኒመሙ እና ማክሲመሙ እንዴት ይሄ ምን ማለት እንደሆነ ላስረዳችሁ። እቺ ቦክሷ ማለት ማጆሪቲው ከዚህ ከ6.4 እስከ 5.1 ባለው ውስጥ ነው ማለት ነው። ማጆሪቲው ይሄ ቦክስ ማለት ይቺኛው 4.3 ደግሞ ማለት ሚኒመሟ ናት። ሚኒመሟ ይቺኛው 7.5 ማለት ማክሲመሟ ናት። ይቺ 5.8 ማለት ደግሞ ይቺ ሚን ማለት ናት። ሚን ቫልዩ ናት። this is the mean value. the top is the maximum value. ይሄ ቦክሱ ደግሞ ከ5.1 እስከ 6.4 ማጆሪቲው እዚህ ኤሪያ ላይ ነው ማለት ነው። ማጆሪቲው በዚህ ኤሪያ ላይ ነው ማለት ነው። ሚኒመሟ ግን 4.3 ናት። ስለዚህ እቺን ግራፍ አስቀምጠን ፊገር ብለን እንጽፋለን። ፊገር ለምሳሌ ፊገር 1 ከሆነ ፊገር 1 እንላለን። then as shown in the figure 1 then describe እናደርጋለን። በቢግ ዳታ ይሄን ዲስክራይብ እናደርጋለን እንዳለ እንደዚህ ሲሆን ይሄን እንዲህ አይነት ዲስትሪቢዩሽን አለው። ይሄ ሲሆን ደግሞ ይሄ ዲስትሪቢዩሽን አለው። ይሄ ሲሆን ይሄኛው ዲስትሪቢዩሽን ለምሳሌ ሜትድ 1 ይሄ የመጀመሪያው ቢሆን፣ ሜትድ 2 የሁለተኛው ቢሆን፣ ሜትድ 3 የሶስተኛው ቢሆን፣ ሜትድ 4 የመጨረሻው ቢሆን እና የተሻለችው ሜትድ 2 ከሆነ ሜትድ 2 ላይ ስታየው ማጆሪቲ ኦፍ ዘ ዳታ ዲስትሪቢዩሽን በጣም ትንሽ ሬንጅ ነው ያለው ብለን እንሄዳለን። however ሚኒመም ቫልዩ 2.2 ቢሆን ማክሲመም ቫልዩ ግን ከአራተኛው ሜትድ ጋር ሲወዳደር 4.1 ሆኗል። but however while the maximum value is large compared to the method 4 but the data distribution is too low, or it is not that much. Majority of the data is at the low range, something so depending on the problem domain we have to do our work. And this is which is called box plotting analysis የምንለው ነው። በ3D ማለት ዶክመንታችን you see the x y እና z dimension የምንሰጠው ማለት ነው። x y z dimension. It is a z dimension. The vertical one is the y dimension. The horizontal is the x dimension. So እንዴት ሶስት የተለያዩ ቫሪያብሎች ኮሪሌሽናቸውን እንደምንሰራ profit, the cost and revenue analysis. ደብረ ማርቆስ ወይም ጎንደር ላይ ያለው የንግድ ሚኒስቴር ወይም የንግድ ቢሮ ነው የሚባለው። የንግድ ቢሮ ምን አይነት ቤኔፊት ነው እየሰራ ያለ? ለምሳሌ ኢንቨስተሮችን አትራክት ያደርግና ኢንቨስተር አትራክት እናደርጋለን ይሉና ኢንቨስተር ሲሄድ ግን ሙስና የሚቀበል ሰው የትየለሌ ነው። ዶክሜንትድ የሆነ ነገር የለም። ሶ እንዴት ነው መሬት 500 1000 10000 ካሬ ሜትር አጥሮ ሰጥቶ they should have some analysis the cost revenue profit correlation እነኚህ ኮሪሌሽኖችን የክልሉ መንግስት የኮስት ሬቬኑ ፕሮፊት ኮሪሌሽን ማሰራት መቻል አለበት እያንዳንዱ የኢንቨስትመንት ቢሮ ላይ so that we can say that in Amhara region the investment office are just benefiting now the people or the region or the investors something ብለን አናሊሲስ መስጠት እንችላለን so this is something it uses for describing the three different variables relevant variables in box plot forms. Here it is a histogram. Just I don't need to discuss about this. It is easier so that you can show using histogram to show the differences of the distributions. The other one is quantile pilot plots. These quantile plots it uses to describe the variable in percent forms. You see, in percent or value forms. Here it is the x the dimension, and here it is the y dimension, so that you can describe one variable in percent. Like for example, investor number, how the investor number is increasing, how the mortality rates of mothers in Amhara region before borning is increasing now or decreasing now in percent. Are they increasing into negative or into positive, something like that. Here it is a scattering data distributions. What type of data distribution they have. What type of data distribution. If you have about how many zones we have, about 7 zones or 1, 2, Gojam 3, Gondar 3 ነው አይደል ጎንደር ያለ ዞን ያለ ደቡብ ሰሜን እና ማዕከላዊ አይደል and then ወሎ ሁለት አለን ሸዋ አንድ አለን አይደል ሶ 1 2 እዚህ ጎጃም እና ጎንደር 3 አለን 6 7 8 9 ዞኖች አሉ ሶ 9 ዞን ላይ ያለ የሞርታሊቲ ሬት ወይም የእናቶች የሞት ዲስትሪቢዩሽን ወይም ደግሞ ኢንቨስትመንት ዲስትሪቢዩሽን we can put የት ቦታ ነው ከፍተኛው ኢንቨስተር ያለው are they highly scattered in Shore or East Gocham or North Gondar or Central Gondar or West Gondar or where it is the majority of the scattering so we have to put very clearly. The other is positive and negative correlation የምንላቸው if this one it is a positive correlations distribution from left to right which is a positive. Here it is the negative distribution የምንለው distributionናቸው just decline እያደረገ ከሆነ negatively correlated ያደርጋሉ ማለት they are apart each other እየተራራቡ ይሄዳሉ similarity measure ማጣቸው uncorrelated የሆነ ደግሞ ምንም pattern የሌላቸው ማለት ነው and here it is data visualization. What data visualization is that? Data visualization means it is again insight into the information space to mapping data onto the graphical premises. It uses for providing quality of data about the pattern, about the structure, about the irregularity, about the relationships between different variables. That is, it is called data visualization. So this data visualization it uses for inciting the data natures to the people. Like for example, it may be pixel oriented visualization. Pixel means that image processing. if you process the image, it is called pixel visualization. It is the blurred image. Here it is the blurred image. By increasing the intensity, we can find the last one, which is such type of transaction volumes or credit limits and so on. And the other one is geometric projection visualization. The projection, this method is used for the presenting the images for the users, the users, or for visualization purposes. Direct data visualization, and there is a scattered plot. This is a very common data visualization, and it has been happening from my work. This also, it is the visualization is how the data is distributed. That was working in the military project like Sagano project. And also, how we can distribute such type of data. How we can distribute such type of data, where the military, the enemy is moving now, just to show the dimension of the mobility of the enemy. We can have the satellite image and then visualize for the security to take action. That is essentially መንግስት ከክልሉ መንግስት ጋር አብሮ መስራት ይቻላል። ከተማረ ጋር መቀራረብ ከቻሉ we can do a lot of researches. They can help, we can help them about the enemy, just using the satellite image, how the enemies are moving now, where majority of the enemies are just acting on that, and so much. Landscapes, the land natures from the satellite image can be visualized in such a manner. This is about the coordinates, XY coordinates, it's about the parallel coordinates, and so much. Here it is churn of faces. የካራክተሩን ጀስት በኤክስ እና በዋይ ኮኦርዲኔት ላይ እንዴት ሪፕሬዘንት ማድረግ እንደምችል here it is streak figures ምናምን የሚባሉ we can show a lot of figures in different dimensions and dimensional stacks and so much. Here it is used for localization. ለምሳሌ የአንድ ይሄ ሪል ላንድ ነው ብለን ብናስበው፣ ለምሳሌ ባህር ዳር አካባቢ ነው ብለን ብናስበው፣ እዚህ አካባቢ ጥላት ሙቭ እያደረገ ካለና ከሚጠቀመው የቤዝ ስቴሽን የኔትወርክ ቤዝ ስቴሽን ምናይ ከሆነ that base station we can manage the mobility of that person. ለምሳሌ አንድ ሰው እዚህ አካባቢ ጉዳት ሊያመጣ ነው እየተባለ ቢታሰብና ኢንፎርሜሽኑ ስልኩ የታወቀ ቢሆን then he stand here then ይሄ ሰውዬ ከየትኛው ቤዝ ስቴሽን እየተጠቀመ እንደሆነ ይታወቃል። ይሄ ሰውዬ ሙቭ አድርጎ እዚህ አካባቢ ሲደርስ እዚህ ከየትኛው ቤዝ ስቴሽን እዚህ አካባቢ ካለ ቤዝ ስቴሽን እንደሆነ እየተጠቀመ እንደሆነ ይታወቃል፣ ኔትወርክ ማለት ነው። ሶ የዚህን ሰውዬ ሞቢሊቲ ኢዚሊ ሃንድል ማድረግ እንችላለን፣ የት አካባቢ እንዳለ መከታተል እንችላለን። so that we can apply such dimensional stacking for easily dimensioning, easily tracking people. It is country mathematics አካባቢ የሚጠቀሙበት country ቴክኒክ ይጠቀማሉ። Measuring data similarity is one of the very mandatory, as I told you before. Proximity, it's measuring similarity in that. It is proximity. Proximity refers to the similarity of data sets. ሁለት ዳታ ለማሽን ለርኒንግ እየወሰዳችሁ ነው ወይም የወሰዳችሁ ሰዎችም አላችሁ። Do you think that machine learning is the most similar data set is very mandatory for machine learning, or dissimilar data sets? Uniform data set is that better, or non-uniform data sets are recommended for machine learning? Anyone? anyone machine learning እየተምራችኋል machine learning ተምራችኋል አይደል? So is there anyone? Yeah, Alamu, go ahead.
ምናልባት ማሽን ለርኒንግ ሲሚላር የሆነ ዳታ ከሰጠ ነው በያዝ ሊያደርግ ይችላል። ስለዚህ ከሁለቱም ካታጎሪዎች ከተለያዩ ክላሶች በተቻለ መጠን እኩል የሆነ ቢሆን ይመረጣል ብዬ ነው ማስበው።
በጣም ጎበዝ። ዳታ ሲሚላር ዳታ ሴት ከሆነ ወይም ዳታ ተመሳሳይ የሆነ ዲስትሪቢዩሽን ካለው ዳታ መማር አይችልም ማሽን። ያ ማሽን ከኤቭሪ ፓተርን እንደ ተመሳሳይ እንዳንድ ነው የሚወስደው። ሶ as far as possible ሪደንደንሲን አቮይድ የምናደርገው ለዛ ነው። በነገራችን ላይ ማሽኑ ከማሽን ሪደንደንሲን አቮይድ የምናደርገው ሲሚላር የሆነ ነገር ስንሰጠው ከሮንግሊ ለርን እንዳያደርግብን ነው። So we have to avoid the similar data sets to make the machine learn more. So more similar የሆነ ዳታ ሴት highly affect ያደርገዋል ማሽናችን ማለት ነው ወይ ሞዴላችንን። So ለዛ ነው SVM አልጎሪዝም ስትማሩ ይሄ ነን ዩኒፎርም የሆነ ዳታ ሴት ሲኖር በጣም ስለሚቸገር KNN ዲስታንስን ካልኩሌት ሲያደርግ SVM እንጠቀማለን። SVM ደግሞ ከርነር ስለሚጠቀም ከርነሩ ትራንስፖዝ ያደርገዋል so that ወደ ሌላ ዳይሜንሽን ስለሚቀይረው የነበረው ሲሚላር የነበረውን ወደ to some extent dissimilar ያደርገዋል so that it uses for computing distances. So similarity measurement ማለት ግን አንድ አይነት ማለት አይደለም። ይሄ ዲስታንስ ካልኩሌሽን ማለት ነው። Distance calculation. If they are the same data, the distance will be 0. If the distance is going to be 1, which is very far apart ማለት ነው። ወይም similarity measure ስናደርግ usually from 0 to 1 ነው የሚሆነው እና 0 ሆነ ማለት just dissimilarity. The distance between them it is 0 mean that almost they are 1 ማለት ነው. They are 1. So when you represent the matrix in different dimensions, if it is a triangular forms, just above the diagonal is 0, below the diagonal is some number, then the distance will be maybe this dissimilarity will be high. So similarity and dissimilarity, it depends on the problem domain. We can say that similar data sometimes relevant or sometimes irrelevant. So we can calculate using a distance computation. Distance machine learning ላይ ስትማሩ የኢኩዊሊየም ዲስታንስ ተማርተዋል። ሲሚላሪቲውን ከአንድ ፖይንት ወደ ሌላ ፖይንት ካልኩሌት የምናደርግበት there is a measurement measuring technique which is called similarity measurement. So similarity measurement usually it has been computed using if it is binary attribute, it is easy. Distance calculation is easy, but there are also dimensional computing techniques like Euclidean distances that uses for calculating distance from one point to the other points. And there is let me show you. Yeah, here it is. Mean distances. It is used for calculating the distance between different objects like xi1 minus xj1. The power of h, which is h is some distance or some defined numbers, and this Minkowski distance, it is a distance computation that usually combine the Euclidean distance and Manhattan distances. There is a Manhattan distance. This Manhattan distance, it is a measurement similarity between the two objects using absolute value. And Euclidean distance is a common computing distance measurement between 2 points using the square root. So these three very important distance measurements are very, very interesting, and usually they are applicable in machine learning, as you have remember. Machine learning ላይ ስትማሩ ምናልባት ስለ ሲሚላሪቲ ያለ የኢንፎርሜሽን ኮንተንት የሚባል ወይም ኢንፎርሜሽን ኮንተንትን እንዴት ኮምፒውት እንደማያደርግ ሁሉም ኢንፎርሜሽን እኩል ስላልሆነ ወይም እኩል ጥቅም ስለሌለው የተወሰኑትን ብቻ ሃይ ኢንፎርሜሽን ኮንተንት ያላቸውን ብቻ መጠቀም ስላለብን ኢንፎርሜሽን ኮንተንትን ካልኩሌት የምናደርግበት ኢንትሮፒ ይባላል። ኢንትሮፒ ካልኩሌት ስናደርግ ዲስታንስ የሚላል ዲስታንስ ኮምፒውት የምናደርግበት አንደኛው ማናታን ዲስታንስ፣ አንደኛው ዩክሊዲያን ዲስታንስ፣ ሌላኛው ደግሞ ሚንኮስኪ ዲስታንስ የሚባሉ የዲስታንስ ካልኩሌሽን ሜካኒዝሞች አሉ። እና ይሄን የትኛውም ቦታ ላይ አፕላይ ማለት ይችላል። you can apply in the machine learning, or you can apply in big data analysis and whatever it is. This is ordinal variables. Attribute of mixer types, if you have different mixer types of attributes, and if you have the standard deviation and some DI objects, then you can compute for binary variables of the distances. Cosine similarity የሚባልም አለ። just cos function and dot product ነው የምንጠቀምበት። x1 times x2 over the absolute value of x1 times the absolute value of x2 ብሎ compute የምናደርግበት። The other one, it is cosine similarity. So this cosine similarity also, it is one of the technique, depending on the problem, depending on the complexity. If it is something like difficult for mathematical operation, cosine similarity can be taken or can be computed. If it is numerical data, Euclidean distance is the simplest one. Or if it is a complex number, the Martin or some other type can be applied for computing the distances. For example, if you have D1 and D2, the numbers, so that the similarity of D1 and D2 can be computed, and then the similarity can be the 0.94, so that this 0.94 is the similarity. Why? Because the similarity is usually it is from 0 to 1. And here, as a summary, you have nominal data, binary data, ordinal data, interval scales, ratio scales, and so more. And we have seen about how data are represented in graphs, or how we can visualize data for different people. And we have seen also how the similarity of data or two different variables, how the similarities is measured, and so on. We have seen from this second chapter. Do you have any question? I hope I rushed out to finish the second chapter, because it is more easy, and you guys can read, and just being the day's holiday, just to leave you guys. Any question you have? ሱራፌል
አመሰግናለሁ። ዳታ ሜዠርመንት ቅድምስ ሚን ስታንዳርድ ዲቪዥን ስንጠቀም ሞዴላችን ሜዠር ስናደርግ 68%፣ 95% እና 99.7% የሚላለና በዚህ በእነዚህ ማለት ሊሆን ይችላል ብናገኝስ ማለት በ68 እስከ 99 ባል ኢንዲቲዩን የሆነ ቁጥር ብናገኝ ተማሪ ይቻላል ነው ሜዠርመንታችን።
ኦኬ የኖርማል በኖርማል ዲስትሪቢዩሽን ምን የሚባል ትችላለህ። ላይክ ለምሳሌ ሚን ሲቀነስ 4 ታይምስ ኦፍ ስታንዳርድ ዲቪዬሽን ሬንጁ አራት ልታደርገው ትችላለህ፣ 5 ልታደርገው ትችላለህ፣ ወይም 3.5 ልታደርገው ዲፔንዲንግ ኦን the standard deviation. ስታንዳርድ ዲቪዬሽን ለምሳሌ 0.05 ከሆነ ከሚንህ ላይ 3 ታይምስ 0.05 4 ታይምስ 0.05 እንዲህ አይነት ነገር ነው የምትቀንስለት እና ዩዥዋሊ እነኚህ ስታንዳርድ ናቸው እንጂ you can test by other ratios like 68% መካከል ሊሆን ይችላል በተለይ ደግሞ በሬሾ ካባዛው like 3.5 ካበዛው 3.4 ካበዛው ሚን ሲቀነስ 3.5 ስታንዳርድ ዲቪዬሽን up to mean plus 3.5 ስታንዳርድ ዲቪዬሽን ብለህ ከሄድክ ትችላለህ ግን ያ unusual ነው ያንን እንዲህ አይነት ሜዠርመንት unusual ነው ስታንዳርዳይዝድ አለው like mean time ሲቀነስ ስታንዳርድ ዲቪዬሽን up to mean plus standard deviation mean times minus 2 times of standard deviation ሲሆን ይሄ ማለት 95% of the data ይይዛል ነው ያለው ግን ኖርማል ዲስትሪቢዩሽን ከሆነ ነው ኖርማል ዲስትሪቢዩሽን ከሆነ ማለት mean እና variance ቱኑ just as the center ከሆነ ማለት ነው mean ሲቀነስ 3 times standard deviation up to mean plus 3 times standard deviation ማለት 99% ተጠቅመው ማለት ነው almost 100% ማለት ነው ከዚህ በላይ አሁን 4 ብታደርገው almost 100% 5 ብታደርገው ቫሪዬሽኑ በጣም ትንሽ ስለሚሆን ነው 7 ብታደርገው ቫሪዬሽኑ almost 99.7% ነው 99.797899 እያለ ነው የሚሄደው እንጂ ብዙ ልዩነት ስለሌለው የአልጎሪዝም ፐርፎርማንስ እንትን ላይ ብዙ ልዩነት አያመጣም ነው ከ68 95 ግን ልዩነት አለው ከ95 እስከ 99 ልዩነት አለው ይሲ ግልጽ ነው ኦኬ anymore ጥያቄ የለም well ፈተና አለን ብላችሁኛል just I will send you one more assignment about the Hadoop install እንድታደርጉ I will attach that assignment as just the first project thank you very much for your attention happy holiday happy Sunday see you bye
thank you
ደህና ዋሉ መልካም ውሎ
እሺ መልካም
you